Bonjour tout le monde, ici c'est Aladdin Physics avec un nouveau physics vidéo et c'est pour un étudiant de A-Level et dans cette vidéo là nous pouvons solver un problème le simple harmonic motion. Donc ici là nous avons une question que comme ça, a box of mass 2 kg is hanged by a spring. The box is made to oscillate vertically without exceeding the limit of proportionality of the spring. The variation with time t of the vertical displacement x of the box from the ceiling is shown in the diagram. There are no resistive forces acting on the box. State the amplitude and frequency of the oscillations. So here the amplitude is going to be 10 centimeter and the frequency is obtained by using f is equal to 1 upon time period, and the time period here is 1 second, so we get the frequency to be equal to 1 hertz. Part B now, first part, state the times at which the box is nearest to the ceiling. So here we have to pay attention to the graph here. The x is in fact the displacement downwards, and the downwards is taken as positive. So here we are going to obtain the time at which it is nearest to the ceiling to be at 0.75 second and 1.75 second. So when it is nearest to the ceiling, the value of x is minimum. Et ça c'est à cause, si tu regardes bien, le film prend x égale 0, cote ceiling là. Et là, toute distance qui est en bas, nous pouvons prendre li comme positif. Deuxième partie, il dit nous comme ça, state the times at which the box is moving upwards towards the ceiling with maximum speed. Donc, si je te rappelle bien, nous avons là, ça qui nous donne un displacement time graph. So, the gradient of the displacement time graph will give us the velocity. The magnitude of that velocity will be the speed. And where the gradient is maximum will give us the maximum speed. So, the gradient at which we have this maximum is at 0.5 second and 1.5 second. And note that we have chosen the negative gradient instead of the positive gradient. Why? Because it is asking when it is moving upwards. So upwards here will be a negative gradient because we've taken positive to be downwards. Now, if we look at part C now, write down an equation for the vertical displacement x of the box from the ceiling with respect to time. So we are going to have x equal to 20 plus 10 sine 2 pi times t. This is a simple sine curve, except that the mean position is not 0, but the mean position is 20. Now part D, we have to calculate first the maximum velocity of the box. So to calculate the maximum velocity of the box, we are going to use v is equal to omega y naught square minus y square. Now, why did I change from x to y is because in the equation, we have to use a displacement from the mean position. And the mean position is at x equal to 20. So, if we substitute the values, we have omega is equal to 2 pi upon t and t is equal to 1 second. So, we have omega is equal to 2 pi. And the amplitude is 10 centimeter. So we have the maximum velocity to be 63 centimeter per second. Now the second part, we have to calculate the maximum acceleration. So in simple harmonic motion, A is equal to minus omega squared y, where y again is a displacement from mean position. So maximum acceleration occurs when y is maximum. So it's equal to 10 centimeter and we get the acceleration to be 130 centimeter per second squared. So the last part now is about calculating the maximum kinetic energy of the box. So in this one, the kinetic energy is simply, for simple harmonic motion, half mv squared. But in simple harmonic motion, basically we can substitute the v in terms of the position with respect to the mean position. Here we have it as y naught square minus y squared. Now we substitute the values here. We get the maximum kinetic energy to be 0.39 joule. Donc toujours, si vous êtes content vidéo là, pas oublier de moi un like et aussi subscribe on the channel et pas oublier aussi share vidéo là si vous connaissez quelqu'un content sa qualité content là. Merci beaucoup, until next time.